Alright. So, I think the biggest problem in your topic 6 is your question. We have 2 conditions in your question. 3 conditions in your question. By the way, good morning, guys. Good morning. Okay, so I think the biggest problem in topic 6 is you have 3 things in the question that you want to identify whether your value given is in equilibrium, they are not in equilibrium, or if you remember, we have one thing called quotient. So whether we are calculating the KCKP straight away, or we need to find by using the ICE table, or we are using the Q. So today concept, alright, more on adalah tackle soalan. Bukan konsep semua kamu dah patut ada, okay? So I just feel bad kalau saya skip, so saya tak nak skip. Lagipun kita memang ada masa pun lagi nak cover. So I want to still stick with topic 6 today. Starting off with more on cara baca soalan, okay? So if you read this question senang, soalan pertama kita sangat senang, at equilibrium. So when you read the question stated at equilibrium. In the other words, all this number of mole given is already at equilibrium. Okay? So when you write your value down, cara kita label value ada 2 cara. Number of mole atau concentration. Okay? So whether you label number of mole initial, number of mole change, or number of mole equilibrium. Sama juga, bila kamu label apa-apa lepas ni, saya nak tahu sama ada dia adalah equilibrium ataupun initial ataupun equilibrium. I think that is the most important thing. Because this is the part that you get confused. Alright? Even though it's objective later on. Jangan ingat soalan objektif adalah soalan yang kamu boleh pegang kalkulator dan dapat jawapan. Jangan harap. Okay? So the first thing is still you answer as always. You take out the value. That is the number of mole initial of SO2. You get it? 0.89 given. And then soalan dah bagi number of mole in, equilibrium. Sorry. Siapa yang nak masuk lagi tu? So, number of mole equilibrium because the question stated at equilibrium. So, kamu pun label number of mole equilibrium O2 sama dengan 2.5. Number of mole equilibrium SO3 equals to 4.5. If you ask me whether your question is tough or not in topic 6, soalan topic 6 tak pernah susah. Soalan topic 6 panjang. Okay? Because kamu bila ada equation, when you have an equation, the minimum thing in your equation is at least one product, one reactant. So when you have product and reactant, you basically need to repeat the calculation, the same calculation. Your ICE table, over here, the biggest problem that student always encounter is, perlu ICE table atau tak perlu ICE table. Okay, yang tu selalu masalah dia, betul. Hampa kadang-kadang bila dah belajar ICE table, semua benda nak buat ICE table. Okay, bila masa nak buat ICE table? That is the problem. Bila soalan bagi initial, ataupun tanya initial. Okay, dia ada bagi atau dia ada tanya. Then kita buat ICE table. Ataupun soalan bagi changes ataupun dia tanya changes. Kalau ada initial dengan changes sama ada diberi atau ditanya, then only ICE table masuk. If you look at our question over here, the question stated equilibrium straight away and the question also straight away asked for equilibrium constant. So, tak dia tanya pasal initial, tak dia tanya pasal changes, dan tak bagi pasal initial, tak bagi pasal changes. Tak perlu ICE table. Okay? So, jangan rasa, sebab selalu masalah budak adalah tiap-tiap tahun kita jumpa, mentang-mentang Han nak belajar ICE table panjang, Han terus datang soalan apa pun ICE table. No, we don't really need ICE table all the time. Okay? So, over here you have the number of mole. Next thing that we want to look for is the concentration. Concentration cara senang nak tulis, concentration letak compound tu terus dalam kotak. Okay? That is the easiest way. Tak payah tulis perkataan concentration panjang-panjang. Everybody should know the formula of concentration, molarity, number of mole over volume, 12 liter. So, kamu akan dapat concentration untuk setiap satu. Okay? But over here, soalan ni tak jelas lagi. Nanti soalan kedua. Just one thing. The way that you label, whether they are equilibrium or whether they are initial. That is the most important thing. Soalan pernah keluar dia bagi changes. dia bagi changes, dia bagi equilibrium, dia suruh cari inertia pun boleh. Okay, so depends on the question. And when you calculate everything, you divide by the 12. Saya rasa concentration tak ada masalah, saya boleh bagi terus. So you have your 0.0472 molar over here. Correct me if I'm wrong. Saya pun tekan calculator sahaja tadi. And then you have your 0.2083 molar. And you have 0.375 molar. Am I right still? Okay, yang buat tekan calculator. Okay, next. Soalan basic, soalan tanya KC. Betul? Formula KC. Asyik tanya, suranya kalau saya tak panggil nama, kelas ni saya tahu siapa yang akan jawab. Suran. So, saya kena panggil nama lah. Okay. Husna. Nak tulis formula KC. Product versus reactant or reactant versus product. Tak dengar. Product versus reactant. Always remember one thing. KC, KP, semua equilibrium constant, semua benda dalam topik 6 adalah product versus reactant. Okay? KC, KP, QC, QP sama. So you have your concentration of your SO3 over concentration of your SO2 over O2. My question, is this correct right now? Is my KC correct right now? Mimi?
No, coefficient.
No. Alright, coefficient tak ada. Benda ni kamu suka tinggal. Alright, benda ni kamu suka tinggal. Sayang, benda ni senang je. Tapi kalau hang nak tinggal tu, hang tinggal sungguh. Jangan tinggal. And therefore, since we need the coefficient in your topic 6, one thing, balance equation. Second thing, physical phase. Alright, kita ambil semua benda bukan sebab kita boleh ambil semua benda ataupun semua yang dibagi kita kena ambil. Tak, kita ambil semua benda sebab semua yang Miss Wong bagi hari ini adalah gas. Kalau semua yang kita bagi adalah gas, that's why we are taking because it's a KC. Benda simple, you should know that, okay? And to calculate the KC, easy. SO3 dah ada, 0.35 kuasa 2. And then you have your 0.0742 kuasa 2, 0.282083 kuasa 1. And then there comes the World War III problem. Tekan calculator. Tu lagi masalah dunia. Alright, COVID is worse. Dengue is worse, what else? AIDS is worse. Nothing could be worse than my student tekan calculator salah. Okay, guys, practice and learn how to use the bracket, learn how to use the kuasa 2. Okay, so you got your answer over here. Memang soalan hari ini tak bagi jawapan pun, kira lah kamu akan dapat jawapan tu, bagi cara je. I think this one has no problem. Okay, the biggest problem that I want to show over here is no ice table is needed. Okay, done. Over here, the first thing I want to show you is no ice table. The second thing, the relationship between your KC, KP, we have one formula. We can change inter between your KC, KP. So, I want to talk about this formula first. Cara nak guna. You have your RT, delta, N. Agree? Okay. Just a kind reminder over here, I don't know whether you realize or not, sebab dalam syllabus kamu tak belajar macam mana nak derive. Zaman saya jadi student, we need to derive this formula. If you learn how to derive, then you realize that this formula is actually coming from ideal gas equation. Alright? Since it's coming from ideal gas equation, guys, therefore, your R constant and your T, your temperature must be in Kelvin. Your R over here, we will fix it. I say I fix it, means no option. I know R, you are having option, but right now I'm fixing it. And since we are fixing it, not I fix it, everybody fix it, okay? Saya ni bila Miss Wong kata, ampun selalu guna ayat tu kat Cik Jan Dilau tu. Yang lain pun sama, alright? Kelas yang tak boleh guna, kelas saya je lah. Tak boleh nak kata apa sebab Miss Wong dah ajar dia tutor juga. Alright, 0.08206 is what everybody fix, constant. Therefore, KP yang kita nak guna mesti ATM. I know KP don't have formula, I know that. But we also know that KP can use any unit of pressure, betul? Soalan bagi millimeter mercury, janji semua orang sama, we can use the millimeter mercury. Soalan bagi torque, everybody is in torque, we can use the torque. But if you are using this formula, your KP must be in ATM because of this. Alright? Because of this. Okay? So everybody must use ATM for this KP. Settle? Dia datang daripada ideal gas equation, therefore the rules cannot change. And your delta N is the most important thing. Delta N is the total number of mole of gases in the product, hanya gas minus the total number of mole of gases in reactant. So, bear that in mind, when I say the total number of mole, we are looking for the gas only. Okay, product minus reactant of the gas only. Kenapa kita hanya tengok gas walaupun kita ada KC? The main thing of this formula is to change your KC to find KP. And that is the reason why we only take count of your delta N. Because everybody should know KP will only take count of gas. Hanya gas ada partial pressure. Agree? Easy. Okay, so for this formula, quite simple, we'll use it straight away. You have your KC already. Just make sure your temperature must be in Kelvin. Just 100% make sure your R value cannot change. Yang tu je lah. Nak guna senang, tak susah pun. Tak pernah susah. Kimia tak pernah susah. Kamu je yang buat hidup kamu susah. Oops. Okay. Kalau saya buat, saya akan kira delta N kat luar. Saya tak pandai macam kamu. Saya akan kira delta N kat luar. That is my product, 2. So I have 2. That is my reactant. Semua adalah gas. 2 tambah 1. So saya ada 3. What I will do, I will calculate the delta N outside. Delta N nak kira tu satu masalah. Delta N dikira dan dijadikan kuasa, yang tu satu lagi masalah. So kalau saya akan kira delta N kat luar. Product minus reactant. So 2 tolak 3. So your delta N today is a negative 1. Delta N boleh jadi any value termasuk kosong. Okay? So calculate your delta N, sayang. Delta N dapat 1 markah kalau Lulu jawab subjektif. Sebab tu saya akan suruh budak kira delta N kat luar. Alright? Delta N, hang formula salah macam mana pun delta N tu dapat 1 markah. Okay? So jangan salah. Therefore, you substitute in your KC that you have calculated. And if I'm not mistaken, it's a 1226211. That is my KC. Okay. And look at the way that I draw my bracket. Look at the way that I put down my value. My R is a 0.08206. My temperature today is 700 degrees Celsius. Changing your degree Celsius to Kelvin, of course. 700 plus 273.15, so you got 973.15. So you have your 973.15 Kelvin, and look at the bracket. Tiap-tiap tahun kita ada isu, budak hanya kuasa N tu dengan R. Saya tak tahu macam mana kamu tekan calculator, but I want to remind you one thing. The delta N that we power off is to the entire of the R and T. Matematik dia bahasa lain adalah sama ada kamu guna bracket ataupun hang darab dulu 2 orang ni weh. Hang darab dulu 2 orang ni baru kuasa negatif 1 tu. Tiap-tiap tahun kita jumpa budak akan darab lepas tu negatif 1 kuasa. Negatif 1 kuasa kalau tak ada bracket, dia hanya akan kuasa pada suhu tersebut. Do you realize that? Okay? So make sure you use the bracket in your calculator. Make very good use of the bracket. The delta N is to everything in the RT. Okay? And then you will get easily your answer in KP. But in my KC and KP don't have unit in our syllabus. Okay? In our syllabus, they tak the unit. Okay? Any question about this formula? Ada yang tak boleh buat? Senang. Tekan calculator je. Dalam calculator tu ada satu benda, ada bracket tau, ada bracket. Tahu? Dan bracket tu hang boleh guna banyak kali. Hang boleh ada bracket, lepas tu bracket, dalam tu bracket, lepas tu tutup balik bracket. God sake, use that bracket man. Okay? Boleh? Easy? Senang. Just be very careful with the and. Make sure the and is your product minus your reactant. The product must be all the gases. The reactant also must be all the gases. And then bila kamu tekan, make sure kuasa adalah kepada semua orang. Yang tu je saya nak pesan. And the rest should be easy. Okay? And this question, ingat ayat dia. At equilibrium, soalan tak minta initial, soalan tak minta changes, dan dia tak bagi. Move on to the next question. Okay? Baca dulu. The question started off with, at 25 degrees Celsius, a series of number of mole is given. Sama macam tadi. Soalan baca memang nampak sama. Kita baca ayat pertama sahaja dulu. If you read the first question only, ada perkataan equilibrium? The first question, Aina Izzati. The first question, the first sentence, ada perkataan equilibrium? Aina Izzati? I think my question is quite clear and simple, isn't it? The first sentence ada perkataan equilibrium tak, Aina Izzati? She's looking at me, but she's not opening the mic and answering the question. Oh my God. Oh, by the way, next time I think I'll be teaching you guys, as in my mentee. Good luck and all the best. Arif?
Tak ada, madam. Tak ada, miss.
Tak ada. Thank you. Over here. Number of mole yang dia bagi kat sini, nak tahu dia adalah initial atau equilibrium. Soalan tak pernah guna perkataan initial most of the time. Sometimes the question will say initial. Alright? At the beginning, initial, time zero, semua tu benda yang sama. Initial, time zero, before the reaction started. Okay, ada. Hang jawab sekarang pun tak apa weh. Sebab saya depan saya still akan ajar kod. Initial, time zero, before the reaction started, ataupun did not mention equilibrium. Bila dia did not mention equilibrium, okay, straight away sayang, data yang dia bagi semua adalah initial. Okay, alright. Semua yang dia bagi adalah initial, bermakna over here I have number of mole initial of the N2 is 0.088 mole. I have number of mole initial of H2 is 0.15 mole. Okay. Volume is 2 liter given. Fine. Gunalah 2 liter tu, tak ada masalah. And then is allowed to react and form ammonia. Then we move on to the second sentence. When the system reach equilibrium, the number of mole of ammonia was found to be 0.025. See the difference of the sentence? Okay. Therefore, right now, bila kamu label your ammonia given, this ammonia given right now will be in number of mole equilibrium. Nampak beza? And guys, even though later on is your objective, I know that is your objective, but guys, this type of question will still come up. This is the type of question will come up. Sorry, I should restructure my sentence. And when this type of question come out in your objective, it's not a question that you can key in everything in your calculator and get the final answer straight away. You still need a lot of papers, a lot of things, but only 1 mark. Welcome to objective 1. All right? We don't even have space for you to do 1 error. I don't know why students love objective. I hate objective throughout my life. Satu, sebab saya kalau tembak memang tak pernah kena lah. Alright? Hidup saya. So yang tu saya tak suka lah. And saya tak suka sebab soalan yang panjang, saya tunjuk macam mana nanti. Soalan ni boleh keluar dalam objektif. Dan dia memang akan keluar soalan macam ni. Alright? This is the level of C3, C4. So, what happened next is you calculate the concentration as always. So, cara label concentration, make sure you label they are right now is the initial or the equilibrium. Putting in 0.088 mole. And do you know why I put 2 liter? Because saya malas nak tekan calculator. Okay. So you have your concentration H2 pula, initial still, 0.15 mole divided by the 2 liter vessels. So you're having 0.075 molar. Agree? Okay, and then what? Okay. Over here, concentration ammonia is an NH3. It's an equilibrium. So equilibrium over here, 0.025 mole divided by 2. So you have your 0.0125 molar. Setakat ni, ada isu? Tak ada. Isu paling besar. Okay. Alright. And this, if coming out in the exam, I would say this is a tougher question. Other than the initial given in this question, what makes this question different from the one just now? Selain daripada initial, selain daripada melibatkan initial, why this question is different from the first one that I show you? Equation. You realize that your topic 6 equation adalah benda yang paling penting yang kena betul before your KCKP. If the equation is wrong, your KCKP bye-bye, question bye-bye, lagi bye-bye. Betul? And that's why I give this type of question. This is the type of question I would say lagi tinggi level dia, where you need to write your equation on your own and your equation must be 200% correct. Okay? Mainly balance the equation. So over here, the question asking for the value of Kc. Before the value of Kc, we definitely need the equation. So it's the reaction between N2 and H2 were placed and allowed to form ammonia. So I have my N2 gas reacting with my H2 gas, forming reversible equation. All right, it's an equilibrium, forming ammonia gas. My question, are we done for the equation? Yasmin say no. Yasmin kena buat apa lagi?
Kena balancekan equation.
Kena balancekan equation. Equation come into your mind, ada dua benda yang kamu kena check. Physical phase, balance. Every single time when you're writing equation, tak ada benda lain yang hang check weh. Balance ke tak? Physical phase apa? Habis. Okay? Afif, nak balance macam mana?
Yes, Miss.
Nak balance macam mana? Berapa mole N2?
Wait.
Huh? Come on, Afif. It's a Haber process formation of ammonia. Satu reaction yang kamu jumpa easily, everywhere, anywhere. You'll be very dead next semester, you know. Afif? Afif?
Yes.
2 mole. How do I balance this equation? Where were you just
at
now?
the NH?
2 mole at the NH3. Lagi? Where were you just now? Why I heard? Kenapa saya dengar suara bergerak dan masuk bilik dan tutup pintu? So you're not even ready for my class. You're sitting in your living room watching Netflix. Lepas tu tiba-tiba Miss Wan panggil nama Afif.
Hey, Miss, your voice is lagging.
Is my voice okay? My voice is okay. Anyway, done? Satu langkah. Okay? Equation get it right. So, kalau soalan objektif keluar, you still need to do this. That's why I give you this type of question di mana equation tak diberi. That is the biggest problem. So the second biggest problem over here, do I need ice table? Like we say just now, if the question gives you initial or the question asks initial and changes. Anything regarding changes means ice table. The question started off with initial. So we know that we need ice table straight away. Cara paling senang nak ice table adalah guna concentration terus. Concentration initial, concentration change. Alright, guna segitiga. Concentration equilibrium. Ni cara paling senang. Tak payah tulis panjang-panjang. Okay, especially kamu nak jawab objektif sahaja. Okay, that is the easiest way. Initial of nitrogen, put it in 0.044 molar. Hydrogen, 0.075 molar. Ammonia, 0.0125. Oliver? What is the initial of ammonia?
0.
Can I know why 0?
Because the reaction haven't started yet, so no product.
Because at initial, alright, at initial, that is my reactant. Your reactant needs to be in the beaker before your reaction started. So if your product is not given the initial, ada soalan yang initial tak mula dengan kosong kalau soalan bagi. Kalau soalan tak bagi, product straight away start with 0. We will assume like what Olivia said, before the reaction, there is no product form. Okay? Next, we go for changes. The changes over here akan bergantung pada coefficient kat depan tu. Agree? Okay? Patricia, can I have the changes for N2? What would you write?
1.
1. Naili, for H2? Fazana, for H2, what will you write? Adiba, for H2, what would you write?
Zero. Negative 3x.
Negative 3x. Thank you. Kita tanya orang yang mesti boleh jawab. Suren, what would you write for NH3?
Plus 2x.
Plus 2x. Alright. Thank you. First and foremost, datang dari mana value-value ni? Okay. First and foremost, before anything, if you can look at it, I have a symbol of positive and negative. The symbol of positive and negative over here is a must. Okay. Apa maksud negative? Apa maksud positive? Negative is when they are reactant. When they are reactant, the negative represent they are being used. The negative means that the concentration will decrease after the reaction. Okay? So it's being used right now, so you need to minus that. While when it's a plus, why is a plus? Because it's a product. So when it's a product, it will be produced. So when it's being produced, the product will be extra, akan bertambah. That's why you will have a minus, minus, and plus. The minus, minus, and plus akan bergantung pada dia adalah reactant atau dia adalah product. Bahasa yang lagi betul is whether it's being used or it's being produced. Okay? And the number over here, the X, what is the X? Sayang, kalau tak suka X, boleh guna Y. Tak suka Y, boleh guna S. Tak suka S, boleh guna A. Any unknown. Okay? That is the changes. The changes were based on what? The changes were based on the stoichiometry that you have. Kalau stoichiometry dia 1, so it will become minus 1x. Kalau dia adalah 3, so it become minus 3x as a reactant. 2 NH3, we produce 2 mole of NH3. So positive 2x. Nampak? The importance of your balance equation. Is that clear? Okay, simple. So your equilibrium lagi senang. Your equilibrium is basically initial minus changes. 0.044 minus x, 0.075 minus 3x, 0 plus 2x. So you have your 2x over here. Any problem with the ice table? No. So the next question is question asking for Kc. If the question asking for Kc, knowing that the formula of Kc is all the values, benda yang nak maksud dalam Kc mesti adalah values at equilibrium. Bermakna value yang kita nak bawa masuk Kc adalah value yang duduk kat sini. Agree? So you need to solve the x. Therefore, how do I solve the x? Afiq? How can Afiq solve the x?
Ambil nilai equilibrium NH3.
Ambil nilai equilibrium NH3. If you read your question carefully, NH3 concentration is given. NH3 concentration is 2x. Nampak? Okay. Therefore, from that, you will then be able to get the x value. Can I just calculate the x value, please, by the way? Can I just copy this thing over? Okay. So I have my 2x over here. Knowing that your 2x is right now equals to 0.0125 molar. So your x straight away will be equals to 6.25 times 10 to the power of -3. Nampak x dia? I look at the way I answer. Tak payah salin balik weh. Sambung terus ke ice table. Jangan tulis kat tepi dah. Tak payah tulis kat tempat lain. Sambung je kat dia. So you got over here 0.075 minus 3 times 6.25 times 10 to the power of -3. So kamu dapat jawapan dia. Which is the concentration at equilibrium. Equals to 0.044 minus 6.25 times 10 to the power of -3. Kira terus daripada ice table. Okay. So that value that you calculated, guys, is the concentration at equilibrium for that. Alright? Sama juga over here 2x, that is the concentration at equilibrium. Kalau student saya jawab subjektif dulu, I will ask them to use their highlighter. Alright, I will always ask them to use their highlighter. Use your highlighter, highlight the value at equilibrium. So when you get the answer of the equilibrium already, you write your Kc as always. Your Kc equals to your product, NH3 kuasa 2, over your nitrogen to the power of 1, times your hydrogen to the power of 3. And you get all the value that you can put in. Nampak? Okay. Boleh ke? Question so far?
Madam,
Yes?
for ice table, can I use number of mole
You
at
can
initial?
use number of mole and then you change at the end.
Okay, thank you.
Alright? Even though I know if you are not changing, you substitute the value of number of mole, you realize that your final answer of Kc will be the same. Because the ratio of everybody is divided by 2, I guess. But you won't get marked for the substitution. Okay? Maka konsep tak ada. But because it's objective, yes, it will be the same, tapi this is the correct way lah. Number of mole is acceptable, but you need to change it to the concentration at the end. Okay, bear that in mind, Kc still talking about concentration. Boleh? Ada soalan? P1? P2? Okay. Alright. Kira sendiri, tak nak bagi jawapan, saya ajar cara je, as always, saya tak suka bagi jawapan, you know me. Saya bagi jawapan akhir je untuk kamu check. Kira lah sendiri. Your Kc calculated, if I'm not mistaken, is about 26 something. Am I right? Ada orang ada jawapan? You got how much? Kira lah, saya nak jawapan daripada kamu. I want answer from someone from your class. Except Suran, by the way. Saya kesian kat Suran sebab Cik Jalila nak buat kelas hari Deepawali. I'm like, tegur saya marah kat dia. Hang okay tak weh? People are celebrating Deepawali and you want to do class terus dia tak buat. Kan? Aina Safia, I want answer. One minute. Olivia get it already?
I got 28.25.
You got 28.25. Yasmin?
I got 23.25.
So many different answer. Lagi? 28, 26. Yang lain? Terus kena pegang calculator. Yang lain?
23.25.
23.25. $23 point. $23
256.
Okay. Alright. Saya salah tekan kot tadi. Okay. Dapat 23 lebih? No, Suran got what?
23.16, but I used number of mole just.
That is maybe because the round off, because when you take the number of mole, you round off the number of mole.
Yeah.
Okay. So. Yang ni tak ada masalah. Kalau kamu akan kalau yang jawapan akhir kamu kat sini betul, alright, then you will be able, then you know all the answer that you calculated just now is correct. Okay. 23 lebih. Yes, saya salah kira kot tadi. Okay. Boleh. Senang. So this is the time when you need ice table because the question gives you initial, but the question asking for equilibrium KC. Just a kind reminder, whenever question asking for KC, KP, all the values that you put into KC, KP must be the value at equilibrium. Okay, yang tu kamu kena ingat because they are equilibrium constant. So every single time when you put in value into your KC, KP, you need to ask yourself, is this value at equilibrium? Okay, because only value at equilibrium can be submitted in. Okay, done. I added up a bit of the question after I sent to you. I asked for the question, I asked for dissociation of hydrogen. Okay, dissociation of hydrogen. Soalan senang ya. If the question asking for percentage of dissociation of hydrogen, yes. So cara nak buat senang sangat, kita akan fokus hanya pada hydrogen gas. Looking at the hydrogen gas and the formula of dissociation is using the change. Okay, Yang kita nak tengok kat sini adalah we are using the change. So the formula of the percentage of dissociation will be the change, concentration change of hydrogen over the concentration initial of hydrogen times 100. Okay. So the initial dah ada 0.075. So we need to find the concentration of change. The concentration change of H2 will be equals to 3x. So knowing that your x is 6.25 times 10 to the power of negative 3. So kamu pun dapatlah kat sini. Alright. So that is the percentage, that is the change of the hydrogen. Substitute in, you have the initial given times 100. And you will have the percentage dissociation. Please. Answer, please.
%25.
25%. Setuju? Alright, setuju? So, apa itu dissociation? Dissociation adalah bahasa pasar dia, weh. Banyak mana kita guna. Itu bahasa pasar dia. The percentage of dissociation or the dissociation is the amount that you use for the reaction. Okay? How much has been dissociated? How much has been reacted? How much has been used? Itu adalah bahasa dia. Okay? And the only difference between the dissociation and also percentage of dissociation adalah darab 100. Kalau soalan hanya minta dissociation, formula yang sama tapi tak payah darab 100. Itu je. Okay? Percentage of dissociation and dissociation, the only difference, percentage. Darab 100. The formula will remain the same. The formula will be forever the change divided by initial. If Suren is using your ice table in number of mole, then your percentage dissociation boleh dalam number of mole. Yang pasti, changes divide initial. If you are using number of mole, then it's number of mole changes divided by the number of mole initial. Concentration seperti yang saya tulis. Kalau pressure pun boleh. Pressure changes divide by the pressure initial. Sama. Okay, boleh. So that is your dissociation and your friend saying 25%. Agree? Okay. Kalau soalan ni, tak tanya langsung ice table. Okay. Dan kalau soalan ni tak tanya KC, soalan objektif keluar, dia jarang tanya dua benda, betul? Saya guna soalan exactly the same tapi tak tanya KC, dia hanya tanya percentage dissociation. Alright. My question. Do I still need to do ice table? Ni dia tak tanya. Do I still need to do ice table? Yes, no. Zulaika? Yes. You still need to do ice table because you need these changes. You still need to do ice table because you need this thing. You want to find the x, kamu dapat tahu negative 3x, negative pula. You akan dapat tahu tolak 3x easily sebab tengok equation, betul? Tapi the question is, what is the x? So you need to still do the ice table to find the x. Okay? So even though the question coming out in the exam later on asking only for dissociation, ice table still kena ada. Is that clear? But in mind, ice table ada 3 orang. Initial, change, equilibrium. So kalau soalan tanya mana-mana daripada 3 tu, ice table kena ada. Kecuali equilibrium kadang-kadang. Okay? So kalau dia bagi initial, buat ice table. Kalau dia tak bagi initial tapi dia tanya initial, buat ice table. Kalau dia minta changes, buat ice table. Okay? Alright? And the last thing before we move on, always remember KC is the only time, termasuk juga KP, Whenever kamu guna formula ni, always ask yourself the value that you put in is in equilibrium or not. Itu sahaja. Kamu kadang-kadang bila ada KC, KP, kamu excited, hang letak je, semua concentration value, pressure value, hang hentam je. Hang kisah apa dia initial ke equilibrium. So yang pertama bila jawab soalan chapter 6, I always tell my student, jangan excited sangat dengan soalan. Every single value yang dia bagi, you need to know the value is initial, changes, atau equilibrium. First thing after all. Then you are good to go. Alright? Last question of the day. So kita dah selesai, dah tentukan how do I know the value is at equilibrium or not. Read the question carefully. Kalau dia tak mention, means dia bukan pada equilibrium. Okay, kalau dia tak ada perkataan at equilibrium, dia bukanlah tu. Okay, and then we identify the question that you need to use ice table. Last question and the easy question. When do I use Q? Quotient. Bila masa aku nak guna QC? Bila masa aku nak guna QP? When the question always have a sentence that sounds like this. Tukar colour, warna hitam pula. When the question always have a sentence that sounds similar like this, is the reaction at equilibrium. Alright, Q tu adalah kita nak tanya, quotient tu adalah kita nak buat macam budget tau. Kalau hang nak renovate rumah, lepas tu hang akan panggil 2-3 kontraktor datang quote rumah tu. Betul? Renovation macam ni, kita nak quote dia berapa harga. So, kita sekarang tengah buat quote. Kita nak quote sama ada keadaan ini, dia duduk kat equilibrium atau tak. Alright, yang tu kita nak quote. Sebab tu kalau soalan yang nak guna QC, QP, soalan yang perlu guna QC, QP, dia selalu akan ada ayat is the reaction at equilibrium. Alright, dia nak kamu cari benda tu sekarang kat equilibrium tak? That is the question that you know Q coming in. Alright, very simple question. Sebab saya memang nak ajar konsep je, bukan nak bagi soalan susah pun. KP given 60.6. Question asking for is the reaction at equilibrium. KP. So straight away QP. Formula QP, kalau subjektif dulu, kita still akan bagi markah. So make sure you write the partial pressure of your QP. Jangan lupa kuasa 2. The entire formula of your QP, QC, KC, KP sama. Masih tengok gas. Masih tengok nombor tepat. Yang tu takkan ubah. Masih adalah product versus reactant. Benda tu takkan ubah. Sama je. Value yang masuk berbeza. So you have your partial pressure NOBR. What makes them different? Kalau KP saya, just want to show you. My KP will be exactly the same. Agree? Alright? And the only things that makes them different is the value that you put in. And I insist just now that the value that you put into your KP or any of your equilibrium constant, value at equilibrium. So yang ni value kat mana? Value not at equilibrium. Alright? Ataupun value at unknown state. Kita tak tahu sekarang dia duduk dalam keadaan equilibrium atau tak, atau lebih. Okay? That is the value not at equilibrium. That is the biggest difference. Next, soalan senang je weh. 5 ATM of each component is in the container. Saya pun letaklah 5 ATM tu dalam tu. So sekarang dalam beaker saya ada semua orang, saya ada 5 ATM NOBR, saya ada 5 ATM NO, saya ada 5 ATM BR2. And the question asking, pada keadaan ini, dia equilibrium atau tak equilibrium? Alright? So, my question. Oh, kenapa laju sangat? Sebab kuasa 2 boleh potong saya. Bukan sebab saya pandai. Saya tak boleh congak kuasa 2 macam tu. Saya boleh congak lah, tapi saya boleh potong lagi laju. So, you got your QP. Senang sangat pula soalan saya. Cheese, tekan calculator pun tak payah. Salah saya. So, your QP over here is 5. Betul? My question, is your system is in equilibrium? Yes or no? No. Betul? Because when you have your Q and your K will be equal if they are in equilibrium. If your Q equals to K, sayang, I write the general one. QC, KC lah. QP, KP lah. Alright? If they are equal, then the system is at equilibrium. All right. If you have Q more than K, or if you have Q less than K, both is not at equilibrium. Logik lah. Kalau dah sama dengan KC, KP, equilibrium lah. Betul? Kalau dah tak sama, tak equilibrium. Logik je. Tak ada apa. Okay? And whenever the question asks for QP, you will always have that 3 things that you need to discuss in the notes. And why I still teach the 3 things. Jangan harap soalan keluar objektif adalah hanya tanya equilibrium atau tak. Sayang, bila kamu dah belajar 1 sem, final kamu 30 soalan 1,5 jam. Hang rasa pilihan jawapan kamu adalah equilibrium atau tak equilibrium. Dalam mimpi pun tak. Okay? So, first sentence, definitely, system not at equilibrium. Betul. Wait, it's reflecting different thing. Sorry. System not in equilibrium. Itu mesti pilihan pertama lah. Betul. Lepas tu, kalau system not in equilibrium, budak akan sentiasa rasa kena hafal. Saya jenis tak suka hafal. Dan saya tak pandai nak hafal. Pandai hafal jadi doktor dah, tak jadi cikgu dah. I want you to look at it. Dia product, dia reactant. Betul. Kalau sekarang, your QP is less than your KP. Ni satu angka pertama. Kalau dalam subjektif dulu lah. Sebab tu dia system not in equilibrium. Sayang, bila dia kecil, nampak dia kecil? Bila dia kecil sebab pecahan produk dia kurang. Setuju? Kan? Dia kecil, value tu kecil sebab orang atas kecil lah. Betul? Directly proportional. Saya sentiasa akan tengok orang atas je. Saya akan tengok produk je. Saya tak akan tengok reactant. Senang, directly proportional. Q kecil means produk kecil. Q besar bermakna produk besar. Nampak? Tak payah hafal. Alright, sekarang Q lebih kecil daripada KP. So Q kecil, produk sikit. So bila produk sikit, tulis apa yang kamu cakap. To achieve equilibrium. Alright. Reactant need to produce more product. Okay. Kenapa ayat ni saya boleh dapat terus? Sebab kita dah decide tadi produk sikit. Kita dah decide tadi produk sikit. So bila produk sikit, apa yang kita buat? Produk tak cukup. Reactant kena tukar pada produk. Nampak? Dan bila perkataan reactant, kat sini adalah reactant, kat sini adalah produk, kita kena tukar kepada produk. Contoh je, reactant kena tukar kepada produk. So, we are shifting from the left to the right. A big misconception that always student will write adalah kamu terikut dengan Lee Chatterley. Kamu akan tulis equilibrium position shift. Every year we come across that. And trust me, kalau saya buat soalan objektif, saya akan buat 2 ayat yang sama. Satu, equilibrium position shift. Satu lagi, reaction shift. And because this one is not in equilibrium yet, bear that in mind, your reaction haven't achieved equilibrium. Equilibrium position tak wujud lagi. Okay? Tak boleh guna perkataan equilibrium position. So, reaction will shift from left to right. Nampak? Okay. Question so far? Am I going too fast or what? Saya rasa cara yang saya ajar sekali lagi, saya tak suka kamu hafal. Sebab bila kamu hafal banyak, kamu masuk exam satu benda je. Blank, blur, terbalik, terlupa. Semua tu keluar lah. Alright? All sort of akan keluar dalam exam. Dia tak akan keluar kat tempat lain. Dia akan keluar during exam. So, my method is, when I was a student, saya tak hafal. Saya guna je matematik dia. I know it's product versus reactant. Dan cara yang paling senang, tak payah tengok yang inversely proportional tu. Tengok orang atas. Tengok produk dia. Kalau Q saya lebih kecil, bermakna Q saya, bermakna produk saya sikit. Sebab Q saya kecil. Betul? So, bila produk saya sikit, bahasa senang lah kalau kamu nak conteng lagi. Tak cukup. Bila dia tak cukup, kena produce lagi banyak. Betul? Tu kalau hang nak conteng lagi lah, kalau nak bagi faham lagi. Saya tak cukup, so saya kena hasilkan dia lah. Siapa yang hasilkan dia? Reactant lah. Betul? So, kalau reactant nak hasilkan produk, dari kiri ke kanan lah. Biasa je lah. Right? And why, even though I know in your exam later on is objective, but I'm still teaching you how to write. Soalan objektif saya pun pernah bagi yang explanation, if you remember. Betul? And you know what's the biggest problem in soalan objektif? When they give you option, and that option is only differ by probably one word. Contoh yang ni. Kalau saya buat soalan ni dalam objektif, pilihan jawapan saya akan jadi equilibrium position shift from the left to right, reaction shift from left to right. And hang dah blur dah. Sebab dalam hidup hang, dia berbeza ke? Dalam hidup hang benda tu sama sebelum ni. Bermula hari ni dia berbeza ya sayang. Okay, betul? So if you come across explanation question dalam objektif, what I will teach my tutorial student, biasanya, I will ask them, jangan baca jawapan dulu. The more you read, the more you confuse. Because the A, B, C, D will be only differ. Trust me, dia akan beza 2-3 perkataan je. Betul? So, kalau soalan objektif keluar dan ada explanation dan A, B, C dia panjang gila, ayat panjang tu, jangan baca dulu. Tutup jawapan tu, buat soalan kamu macam biasa, kamu tulis explanation kamu dulu. Sebelum kamu blur, sebelum kamu di-confuse oleh jawapan, sebelum kamu lepas baca A, B, C, D, apa benda aku nak buat? So, dia increase ke decrease, hang lupa semua dah. Betul? Alright? Because the more you read, the more you are being influenced by the answer. So, kalau soalan macam ni, calculation saya tak risau sangat. Calculation sama ada hang kira betul atau hang kira salah tu je. Tapi kalau ayat tu, the more you read, the more you will like, so A ke B? Kenapa A dengan B lain ke? Hang pula kena cari apa dia beza. Tak payah. Bazir masa. Alright? If the objective question come out is explanation, answer on the paper. Contoh dulu, write your explanation. Cari jawapan yang sama dengan explanation kamu. Then you got it dah. Okay? Easy? Simple. Alright? So over here, just a very quick one to recap. I think most of the time, I think Suren doing the mistake. Suren dok ngangguk tak berhenti tadi. This one. Whenever it's talking about Q, we never use equilibrium position. Always remember, we discuss Q because the system is not at equilibrium yet. So equilibrium position tak wujud. Kalau kira Q, explanation kena guna perkataan reaction shift from where to where. Lain dengan Le Chatelier. Le Chatelier adalah sistem kamu dah equilibrium. Kamu tambah disturbance. Betul? Alright? So over here is different. The system is not equilibrium from the beginning. Is that clear? Okay. Any question? I hope I help you a bit. I hope you get something over this 1 hour. I know most of your class has discussed. Okay. If you have any question regarding topic 6, any camp friend that you cannot do, any question that you cannot do, drop it and I will answer it. Okay. PM me. Okay. Ada apa-apa yang tak faham bila masa boleh guna ATM, bila masa tak boleh, ask me. Okay. And at the end of the day, ladies and gentlemen, tekan calculator. Betul. Betul. Yang tu aku nak buat apa khusus tekan calculator. Pertandingan tekan calculator. Siapa tekan calculator betul, then tak payah masuk kuliah Miss Wong. Terus semua tekan calculator betul. Alright, have a good day, have a good week. We will be going into topic 7 next week. Okay? We'll be going into topic 7 next week. And the last week, we will do a pre-PSPM. That 1 hour last week, minggu hujung tu, we will cover all chapter 30 question. Tapi 1 hour and a half. Mungkin buat malam lah. Mungkin kita buat malam. Okay. So we have 3 weeks to cover topic 7 and then the last week we'll be doing your pre-PSPM. And let's see how you die vomiting the questions, answer and everything. Soalan susah? Of course, mana boleh bagi soalan senang? Okay. Alright, if nothing else, have a good day. I'll see you next week for topic 7. And if you have any question, just drop it and PM me. Thank you.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Thank you, ma'am.
Thank you, Miss.
Thank you,
Thank
Miss.
you, miss.
Thank you, Miss.
Thank you, Miss.
And everybody in the line is so good right now when you say thank you.